So I will be explaining with you the meaning of augmented matrix. An augmented matrix is just a matrix that which you would be taking out the constants of your systems of linear equations. So this is a systems of linear equations in x, y, and z. We would like to take an augmented matrix out of this. So what we will do here is to take out the numerical coefficients of x, y, and z. In the first equation, you would see that the numerical coefficient is 2. For x, the numerical coefficient for y here is 3. And you don't have a z term, so you will have to put 0. And it's equal to the constant value, -10. Usually we put something like this, hidden lines to indicate that the equation is equal to this number. For this equation, you don't have an x term, so you will put 0. You have the y term, which is 5 for its numerical coefficient, and 3 for z, and then you have 1. For the third equation, the numerical coefficient of x is -5, and the numerical coefficient of y is -1. If it doesn't show and there's a letter, it means that the number beside it is 1. And you don't have a z term, so you put 0, and then a constant value 2. So this one, now you have an augmented matrix of which it has 3 rows and 4 columns. So the order of this is 3 by 4. We also call this as the dimension of our matrix. Now this would be when all the terms in all the numerical coefficients of your systems of linear equations are in standard form. But however, there is also a situation where the equations are not in standard form. In the first equation here, it's in the standard form. Standard form means that your equation, in this case, it's in the term x and y, and it's equivalent to c. So the first equation is in standard form, so you can take out the augmented matrix. For this, that would be for the x term 2, and for the y term 3, and our constant value is 5. In the second equation, it's not in standard form, so what we will do is to put it in standard form in the form ax plus by equals c. So it means that we will have to write first x. Since it's already in its proper position, you will not change anything to it, so you put 2x. Then you want the y term, but it's on the other side of the equation, so you change the sign only. Put as negative. And 6 is not also in its proper position because that's your c, so you also change the sign. Okay, next. So we want the x term. The x term is not in its proper position, so you change the sign. 5y is in its proper position, you don't change the sign. And since we already have a transpose x to the other side, there's no constant remaining, so you will put 0. So therefore, the numerical coefficients of this is -2. This one is -3 for y, and our constant value is -6. This one, you have the x term with a numerical coefficient of 1, and the y term with a numerical coefficient of 5, and it's constant to be 0. So this one is a 3 by 3 matrix. That's the order and the dimension of the matrix. Let's have another example. Let's say you have this. So you have your x term for the first equation to have a numerical coefficient of 5, and the y term to have a numerical coefficient of 2, and it's constant at 12. Since this is already in standard position, so you don't put it in another form. It's already in standard position. This one is not. So as you can see, it's either you simply use symmetry. Since it's already like similar to this, you can simply make use of the symmetric property by exchanging the positions of the left side and the right side to each other, like what you have. And if that happens, when you put the left side, the whole left side, to the right side of the equation, okay, you don't change the signs. Same thing also if you have the right side, put it on the left side of the equation, the whole of it, you don't change the sign. We call it the symmetric property. So the numerical coefficients of these will be 3, -4, and 6. In this situation, we need to transpose to y. So therefore, since it's not in its proper position, we will change the sign. So this now becomes 2x, 2y becomes negative. Since we are not transposing -5, we will have to write its original form. So therefore, the numerical coefficients of this would be 2 for x, -2 for y, and -5 for the constant. So again, this is a 3 by 3 matrix. It has 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. And that's it.